Hello there, I'm Mr. Black, and welcome to Friday Science. Woo! This is for anyone. You can do this along at home. So today we're going to ask the question, does a paperclip float? Let's have a look. Got my water, got my paperclip, go. The paperclip doesn't float. So, is there something we can do to make the paperclip float? Well, I got an idea. A piece of tissue paper, and I've got my water. That's probably pretty good. And I'm gonna cut it, rip it, I guess, to a fairly small size and place it on top. Then I'm gonna put the paperclip on top of the tissue paper. And then I'm gonna take something like a pencil, and push the tissue down to the bottom of the container. Slowly. Actually, if it's tissue, you might just need to take the whole thing out. And the paper clip is floating. Wow. That's pretty crazy. What is going on here? What's going on is a phenomenon called surface tension. And I'm going to explain a little bit more in a second how surface tension works. But what you've just seen was not a science experiment. It was a science demonstration. I've just demonstrated to you how this paperclip can float. But I've not actually tested anything. I've not come up with a question to try to solve with some sort of experimental process. I've just shown you a phenomenon. Okay, so your challenge today or the weekend, the rest of the week, is to turn this demonstration, I don't want to disturb the paperclip, turn this demonstration into an experiment. And how do you do that? You ask a question. Okay, maybe you ask, or you're wondering, you're curious, how many paperclips would the surface of this water support? So you could test that. You could add paperclips and see, is there a limit? Do all liquids have the same surface tension? There's another experiment. You can do this with water, do it with milk, do it with oil, do it with apple juice. That would be really interesting. Maybe you want to ask a totally different type of question. Is it only a paperclip that can float? Is there something about the metal? Can I put something else that's even heavier in there? What's the heaviest thing I can put in here and have it float? Well, we can just keep going. So I'm curious to see what your questions are and what kind of experiments you can come up with. So thanks for watching. That's the end of the video. If you're really curious about how surface tension works, you can keep watching. I'm going to explain it just a little bit. It's a pretty cool phenomenon. Very useful in science as well. Bye. Hang on, are you still here? Are you still watching? Okay, I guess I'll explain a little bit about what surface tension is, just for the curious. So, I'm gonna write this down here. Surface tension. The paperclip was floating on water. And we know that water is sometimes called H2O. Now, what you may not know is what H2O means. The H in H2O stands for hydrogen, and the O stands for oxygen. These are called elements, and when you put them together, you get water, H2O. One of the ways we can sort of model or draw what water looks like when it's a molecule is by drawing its structure. So I do it this way. I've got one H atom here, hydrogen atom here, and I've got one hydrogen atom over here. And they are connected by an oxygen atom. It kind of looks like a bug, doesn't it? It's pretty cool. So that's a water molecule. This whole thing around here, this thing right here, this is a water molecule. So how does that relate to surface tension? Well, I'm about to show you. Let's grab this water molecule and copy it, and I'm gonna need some more space, so I'm actually gonna go over here. Okay, so I need a few of these water molecules. Just bear with me while I do this. Isn't this program cool? I really like it. Thanks, Mr. Colville. Scoville's a legend, guys. Okay. Now I'm going to take the whole row and duplicate. So I've got lots and lots of water molecules. Look at that. Oh, that is so cool. Okay, so all of these structures here are water molecules. And they are not only it's not only that hang on, where's my pen? Okay. It's not only that the hydrogen is connected to the oxygen like this, but in fact, these water molecules are also connected to each other. So there's a connection here, for example. There's a connection here. There's a connection here. And now it's not the same type of connection, but I don't need to go into detail about that. That's a little bit too technical for our purposes. Just know that these are connected, okay? So let me just move a bit quicker here. I know it looks a bit sloppy. These are all connected. This is the water. The water is connected. And you kind of know that water is connected, don't you? Because when you drink it, it's not like it just kind of all crumbles out of the cup. It flows. It's clearly connected together somehow. Okay. The water is all connected to itself. We're going to pretend that up here is the air. Therefore, this is the surface of the water. You see that? That's the surface of the water. What is going on with surface tension is that while underneath the air, in your cup, you've got these bonds happening, the water is connected. Up here at the top, these topmost water molecules, they can only bond with maybe their neighbor or down here, but there's nothing above them to bond with. Right? There's no water above them, it's just air. So what they end up doing is just making these bonds even stronger. It's almost like the energy or the available space for them to bond is strengthened because they don't have a lot of neighbors. So when that paperclip, here's paperclip, okay, and I'm going to just copy it here so I can grab it. When that paperclip is dropped, it just falls through the water. But if I lay it on the tissue paper and then slowly take the tissue paper away, there's enough surface tension here to counteract the force of gravity. Paperclip has very little buoyancy as well, and it just floats on the surface. So I know that's, oops, what did I do there? No. I know that's, oh, I did it again. I blame Mr. Colville. No, just kidding. So I know that's a very rough description. You probably have more questions than you do answers, but that's probably about as basic as you can make surface tension when you are starting to talk about atoms. Okay, anyways, good luck with your experiments. See you later.